Good afternoon mga Bisaya. So in this video, we will be discussing um, framing plan, but this time this will be framed using a, like wood framing, light framed um, wood. So it would be framed with wood stud, um, wood roof trusses, and wood roof floor joist. But before we proceed with this one, I just want to clarify this one because this is somehow related to our topic today. So I saw this post in Facebook. So this one, his caption was, or her caption was, low distribution, um, for structural plan, like framing. And then when I look at it, if you noticed, basically what he did is in the tributary width for this or area for this particular framing is what she did was just basically divide this into two. So there's one half and then divide this into two as well, like this length. The tributary width. The tributary width for that beam is this one. But I told her like that's not how you distribute the load. I mean, if you noticed, this is 5 meters, this is 3 meters. So that means our short span, no, our short span W, if this is W, this is L, then L over W is less than, in this case, is less than 2, right? So if that is less than 2, that means that's a two-way slab. And then the way it is distributed is for this particular beam, like this area, this is slab, you will do like a 45 degrees. And then the same here on this side, 45 degrees. And then this area is the one being transferred to this beam. No? And then this triangular area here will be distributed to this beam here. At the same time, basically on the other side. So that's how it is distributed. You just don't divide this one unless, like I said in my caption here, because I reposted her post. So basically, I said that's not how floor loads are distributed to the beams. That's a two-way slab unless you are using a floor joist. Now, talking about floor joist, this is what we're discussing today. So we will try to do a framing of this building as if we will do like a light frame, like wood. No. So if this is, for example, this is, like I said in the previous video, we'll assume that this will be the same um, like footprint on the roof level, second floor level, and then the main floor level. So assuming this is the main floor level, and this will be a typical like building footprint on the upper floor. So if this is the same, like if we are looking at this one as the second floor, then we will frame this with, for example, if the beam or if the building and the roof layout is like a gable, then usually the roof framing would be, of course, this will be trusses. I mean, if there is like say parapet or oh no, I mean this, for example, first this is a gable roof, so there will be overhang. So usually for wood truss, the typical spacing is 2 feet on center in that direction. So this is only what 25 feet. That's easy. I mean, I've seen trusses that spans like 50 feet, 60 feet, no problem. So this is when you do the roof framing plan, that's easy. All you have to do is just draw like draw like a roof trusses layout here, and then your call out will be pre-engineered because all the trusses, like wood floor truss or wood roof trusses are pre-engineered. It will be done by another company, or well, you can design it yourself. But the way it's done here is, all you have to do as the engineer of record is you do the um, roof framing layout, and then the truss manufacturer will follow your layout, and then they will design based on your specified load. So in the roof framing plan and floor framing plan, you will have your design load where you specify the dead load, the superimposed dead load. No, you will specify the dead load, which is SI, the superimposed dead load in live roof live load or snow load, mm, snow load, and then the wind load. Now, like at first, assuming this is a gable truss, then if you look at the section, if this is your building, this is your wall, it will be like this one. So it will be like that one. So, and this is pre-engineered. We just call it out as pre-engineered um, wood roof trusses at 24 inches on center or 2 feet or 600 millimeter on center. So that's how it's done. And then on the side, because you have cantilevered portion or like a overhang on this side as well, what we usually do is we'll do something like this one. So this is your end wall, right? This is your end wall, and then this is your roof line, like bearing top of wall elevation. So you have your trusses, and then this one, these are the trusses at 24 inches on center. Now this one we call this out as reduced end truss. So what it does is basically the height of this truss is, say, if you're we call this one a trigger, you will frame like this one. So that this will be, we call this out a trigger. Some structural engineers will call that one in their layout as ladder framing. So that's how it is framed. So it will be bearing in here, and then this will be attached using a joist hanger. Usually this is 2 by 4, sometimes 2 by 6. It depends on the load, and that is how it's framed. We'll see if I can find a sample of that one, but um, I have here a layout. So this one. So usually when we submit or when we do the IFC drawing, then the contractor will forward the roof truss layout to the or roof framing plan to the truss manufacturer, and then they will do like a truss layout as well. Make sure that it will be the same, or when they submit this as a shop drawing, the engineer of record will review everything, ensuring that all the loads are correct, and then the trusses layout are correct, and then they will also submit the calculation. So this is a typical truss layout of a gable roof, then with the hip in this side here. So these trusses in this area are called valley fill truss. So these trusses are still full length, and then there will be a beam here. So if you cut section there, it will look like this one. So this is your trusses, and then this one is supported by a wall, like load bearing wall. And then on this side, there's a beam. So that's a beam. And then this is the same truss bearing. There will be a beam here. It depends if it's, if there's a wall, or in this case, I think it's a beam also, and then another column here or post. And then on this side, this will be a full depth truss at 24 inches on center, and then you have your reduced end truss and then your outrigger. And then on this side, it will be, it is called the valley fill truss. And then the height will be different at its location, something like that one. So that's how it's done. And then this one here. This is a full truss, and this truss is has a special loading to support the extra dead weight here for the valley fill truss. And then for the floor, for the floor layout. So assuming this is the same building, for the floor layout is the same. All you have to do is, now this is 25 feet. So I don't know if um, a joist. Usually, what I'll do is I will do a quick calculation. Let me just. So this is using 40 web, and then when I do like a quick calculation of the um when I do a quick calculation of the what we call this one, quick calculation of the joist, just to get the initial depth. Then what I will do is I will do a quick calculation for, so this is residential application, and then you will do like a joist, and then this will be, span is 25 feet, right? 25 feet, and then say our wall is say 2 by 6, so that would be 5.5, 5.5 bearing. So this will be 5.5 stud wall, pin board, and then this is about clear. And then your load. So for example, once you calculate your dead load, like floor dead load, you will have, say, assuming that's 20 psf, and then floor live load is 40. That's for residential application. Like I said, if you look at the occupancy level load in your local building code, you will see the recommended floor live load for residential or whatever occupancy it is. And then on top of that, you will have the partition load. Now, like I said, make sure in your, like you refer your partition load in your local building code. Make sure if that partition load is defined as a dead load or a live load. Now, I already mentioned this in the previous video, that in the Canadian code, partition is considered as dead load. So we will add the 20 piece if dead load. Now, this one, by the way, this is FortiWave. This is a free software for Warehouser products. And then all you have to do is really um, change the, or just use their product here. And then, well, if you specify, if you use this FortiWeb, then you will specify Warehouser product, and then um, it will be your basis for, like specifying like sizes of your um what we call this one, floor joist, and supplier manufacturer, because this one TGI, this is specific for um warehouser products. So if we use TGI, then say 360, and then say 18, usually floor joist spacing is 16 inches on center. So if we say that one. So in this calculation, if you look at the moment is only 34%, bearing is 52%. So this is like quick calculation. If ever there is a failure in the one of the strength requirements or criteria, like ultimate strength or the serviceability, it will be read here. For example, if I will use say TGI 110 and then 1178 and then that one, so you will see all this read, that means it failed, right? So again, in this one, if you use TGI 560 and then your floor joist depth is 16, spacing is 16, then number of plies is 1. Now on this one, our bending is only 39%, the deflection is 0.98, no, 0.511, so you have about just over half inch of deflection. So if you think this is enough, then you just have, already have a preliminary size, and then you talk to the architect if if 16 inches is okay. Because sometimes we have to follow whatever the clearance requirements. Because most of the time when I start floor framing plan, I will look at also the building section and then see how much is the clearance from the architect. If they say they provide enough space for a 16-inch joist, then you will size for 16-inch joist, 16 inch. If it's only like 11.78, for example, if you run 11.78, you will notice that it failed in live load deflection. By the way, live load deflection, um, the criteria would be, because this is improve it, the minimum is elevator 60 for live load. And let's go back to the calculation. So it still failed in TGI Pro rating. And then this one, system vibration control. Now this failure is more of a serviceability, and what the effect of it. If this one failed here, most likely it will be bouncy, although um, it's still okay. It's not failing. It's just, when you walk over it, it will be bouncy. That's what it means when this one here, TGI Pro rating and system vibration control, like failure on that criteria. So what you can do is either, if you are limited to 11.78, then what you can do is make the spacing closer. So if we do 12 inches on center spacing, right, still failing. So if you do, 2 ply at 19.2, still failing. So this time all you have to do is say it's either talk to the architect that we really need, um, let's try 14 inches. Maybe it works. 14 inches, 16. They're still failing. So you have to talk to the architect and say, hey, we need at least, if we clear this whole span, whole width of the building, we need at least 16 inches 16 inches joist. Or if you want to limit the joist depth to 11.78, all you have to do is just tell the architect, okay, if that's the case, then, we will use this as a load bearing wall. This one will be load bearing wall, this one. And then you will run a beam on this one here, and then another beam. So there will be like beam, load bearing beam inside right here. So there will be load bearing beam. And then, so to avoid any bulkheads, what you can do, you can tell the architect, okay, to avoid any bulkhead, what we can do is we can do like a flush joist. So what it means is, if this is the if this is the beam, you know, regardless how many ply, another one way of framing it is you will just run the joist on top. Now this will be a bulkhead. If the architect doesn't want any bulkhead, all you have to do is just flush the floor joist. So it will be right here, and then the joist would be right here. So this is beam, and then you will have a joist hanger like that. So I will show you a sample of um, what it looks like in the actual. Where is it? Give me a sec here. So in this picture, you will see the joist. So this is a interior load bearing wall. This is an interior load bearing wall, and then the joist is, continuous. And then you will have, this is top bearing. So for example, like in this calculation, you have 25 feet span, but you decide, okay, we'll make the interior wall like load bearing. So this will be 12.6. Why is this concentrated load? Let me double check the load. But let's check the span first. So this is 5.5. Why is the load? Oh, because this is used to, it's supposed to be uniform load. That one. So in this case, if you know 1178, say 360, 16, 1 ply. Now, if this is okay, see, this is okay now, then like I said, all you have to do is make the interior load bearing more. So this what it looks like if you are in this area here. So assuming this is load bearing wall, this is load bearing wall. If you are looking in, if you are looking at this angle here, looking at the you know at the wall, and then the joist would be in this direction, then what you can do, or what it looks like, is this picture here, this one. Now in this area where you have beam, where you have beam here, and then that's flush, then it looks like this one here. um well, it looks like this one. There will be like a hanger, but the issue is the beam is really deep. So that's why this is only the floor is only 11.78. I think the beam size on this project is 18 inch. Let's see if we can find another one where the joist is, or the beam. I don't think I have a sample here, but anyway, just in case, it will end up like really big beam. Then another option is like using a steel, and this is what it looks like. So this one here. So you have a steel beam instead of wood beam, and then you will have a joist or a floor truss. Now this is a floor truss. So you have another option. You have another option for your floor framing. Instead of using a TGI joist, TGI joist looks like this one. So you have like some kind like a flange, and then it depends on the type. If this is 360 TGI 360, this is 3.5. From there up to here, that's 3.5, and then this web is a plywood, and then it will be glued here, glued. So that's TGI. Now, in this picture, what I'm showing is an open wave floor truss. So you can do the for example, for a regular like gable roof truss, it will look like this one. But if it's a floor truss, it will be flat. Mm, It will be flat. So this is your top chord, this is your bottom chord, and this is your vertical members, and then you will have diagonal here. Now it depends on the configuration, geometry of the truss, but that's what it looks like, floor truss. And this can span much longer than just the TGI because you can customize the top chord. This could be engineered wood top and bottom chord, and this one regular like 2x6 or 2x4. So that's for framing. Now this one here in picture, this is a floor truss layout from the joy supplier. So usually, like I said earlier, in my calculation, I use the 40 web. And then sometimes if the contractor will send the floor framing plan to a truss manufacturer, some manufacturer have different supplier. So because of that, they will provide an alternative instead of saying this one, shall we say TGI, for example, in our framing plan, this is TGI, say TGI 360 at 16 center. They will specify an alternative, whatever is the product from their supplier. And then if this is the case that they are offering alternative, then they have to submit a shop drawing with a stamp. So it needs to be stamped by an engineer before we accept a alternative. And then in some projects, it's funny because one of the truss manufacturer here, we are the engineer of record for all their designs. And then if the contractor submits the drawing to the truss supplier or the joy supplier will do the truss layout and the forges layout, send it to us for basically for stamp, and then we submit it back to the contractor. Then the contractor will submit it to us. So basically, we are sometimes I am checking a shop drawing that I stamp. So sometimes it's funny, but it happens because, like I said, one of the truss manufacturer here, we are the engineer of record of all their trusses. So um, going back to the floor plan, so this one here. Now, looking at this one here, so we already decided we will use the interior load bearing as a load bearing wall. So that means, remember this is an opening, right? So that is an opening. So all you have to do is from here, like I said, we will have a load bearing beam, or we have a beam. This is load bearing wall in another beam. And then it depends. Sometimes we will design a beam this way, another beam here, and then it will be supported by a beam here because this is a could be window opening because this is a stair porch, so that could be a window opening like a glass. So there will be a beam here, then another beam here, and then in this area we'll be designing a there will be a column here or post. So if a 6x6 post or 4x4 post is enough, then that would be your post size. But for example, if this is limited to a 2x4 or yeah 2x4 wall, that means the width of the stud or the depth of the stud is only 3.5 because that's the dimension, the actual size. Say a 2x4 stud or a wood, the actual dimension is 1.5 by 3.5. So if that's the case, and then your minimum wood size is say 6 by 6, then your option would be go a like a telepost. So it's called telepost. Um, so telepost, it's in some drawings it will be called an adjustable post. So this is what it looks like. This one. I think in one in the picture, the one in the picture is telepost next is this one here. See? So this is sometimes this is only 3 by 3 HSS hollow steel section column. There will be like a 3D rod here that can you can adjust, just turn the nut and then it will adjust the height. And that's what it looks like in this one. See? And then it has a capacity. Now it's depending on the size of the post itself, then it has different capacity. So you just select um or if you are the one specifying the type of you know type of daily post, then you specify the actual model number depending on the capacity. But sometimes we will just leave it to the contractor to choose the supplier, and we will just say this is telepost. In the drawing, we will specify telepost, and then we'll specify the minimum uh, capacity, say 10,000 pounds minimum capacity. So that's what how we specify in the drawing. So that will be telepost. Now in this case, because we have a beam here, now our joist will span the whole length. So instead of making this load bearing wall, and then you have a short span here, all you just have to do is, run the joist all the way up to the opening like that. So this will be different joist design, and then a simple span. And then another joist in this location will be continuous. I mean, it doesn't have to be continuous, but most of the time it's continuous because TGI joist, this one, usually this is the maximum span of this is 40 feet. So you can order, I mean, this is 25. See, this is only 25, so it can span. But if you specify this one, this will be they will they will deliver like a if this is 25, they will deliver at least 26 feet because they always add 1 foot just for tolerance. So this will be a continuous span, that one. So that's how you frame, like do the floor framing. And then this will be opening, and then this is a beam, this is a beam, and then this is a beam also. And then you have another, I mean, the joist here could be, I mean, this is a flush beam. Then this will be a separate joist here, like a really short span. Sometimes we specify only, 2 by 8 or 2 by 10. But if you want like, the same ceiling height, you don't have to provide some shims. Then even if it's overkill, then we will specify the same joist here, the same as this joist on this area. So that's how it is framed. And then, well, wherever there are openings, then all you have to do is provide a header. Now in 40 web, there's a calculation also for that one. So if you look at this one here, see this one here, wall, that's a header. Or you can design it as the same as a beam, but just use this one here. So, and then you specify the load. So this one, you already say your span is 5 feet, and then your loads. So instead of inputting the load, all you have to do is you already design the joist. Then all you have to do is just link the reaction from your floor joist. Say this is in the perimeter because we are designing a header. Then it's either you know say if we are designing this beam here, this is on the right side. This is support one here. Uh, this is your support one, support two, and then support three. then that means in the 40 wave calculation, all you have to do is select with support, and then if that's uniform, and then say 5. Um, so the total length would be, because you have a 3 meter which is 1.5 by 1.5, 1.5, and then on each side, so this will become 5 foot 3. Your span, so your load would be 5 foot 3, and then you select a regular joist or the regular dimension length, say 3 ply 2 by 8. Then if it says, if it's okay, then that's your final size. It could be 2 by 6. Maybe 2 by 6 will be okay, but we typically specify minimum 2 by 8 for structural. Is not to over design, but sometimes if ever there are renovations in the future that would affect the header size, at least we have extra capacity. That's basically the main reason, because um, if you are working on a, for example, residential or shop building, you will really experience that there will be a tenant improvement or renovations in the building. So there will be changes in the loading. So that's why it is better to just over design that one. And yeah, like I said, minimum is 2 by 8. That's what we typically use, 2 by 8. So in this case, so we already did the framing plan. So this is a residential building, so it's really easy. And if we go with this one here, now if you notice, we have interior columns, because this is really a big building. So usually what we do here is, if you notice, there is already, I mean, if there are none, specified like column locations here, you can talk to the architect that, we need columns along this grid line to cut the slope. And this is usually better for the architect, because usually in this kind of building, it will be flat roof. And then if that's flat roof, this is where the change in slope, like that. So if you look at the cross section, it will be look like this one. I mean, I'm just exaggerating the slope. So this is the wall. This is the wall, load bearing wall, and then there will be column here with beam, and then usually this is one half by one half is to 12 slope, or one is to, it depends on the. I think the minimum is one quarter, like one fourth inch is to 12, or one quarter is to 12, not inch. So that's the minimum slope for a flat roof. So if that's the case, this is where the lowest portion of your, because you can always slope the truss, this one here. If that's the case, then you will run your I don't know, in here I think the wall is jog right here. So this will become a load bearing wall, and then you know your truss will run in this direction, like that. It will be monotruss, single slope, monoslope in this direction, with slope in this direction, and then on this side it will be sloping that way. Then this is another monoroof trusses, that one. Like I said, we've seen like trusses before, like 50 feet, 60 feet. It will be deep. I mean, it will it will be really deep, but it can be designed. So yeah, that's how you frame. And then this will be, it's either, if you are doing like a flatwood framing, then this can be a load bearing wall with headers, and then this one load bearing wall as well, and then load bearing wall, and then in some instances this could be steel columns, steel beams, and then just non-load bearing exterior wall. So that's another possibility. Now I will have here a sample. um, this is a like a shop. If you notice, like I said, so we have the interior columns here, and then on this particular building, instead of steel beam, we are using engineered wood. So if I remember correctly, this is a four ply, um, 24-inch LVL. So if we cut section in this beam, it will look like this. It will look like this. So this is your beam. So this is a four ply 24-inch LVL. And then the trusses are top chord bearing. So it will slope in that direction. So it's a top chord, you know, top chord bearing, that one. And then the other in the other direction, it will, because these are like offset from each other, so it will you will have full bearing, 7 inches bearing. Or if the bearing requirements, if you only require, if it only requires two ply, like that's 3.5. If 3.5 is fine, then you will butt the trusses at the mid at the mid location. But usually, what we do is specify this will be like a full bearing. So you have to, if this is the beam, the layout, it will show. You have to show that in the layout, it is offset from each other. So this is the truss. So that the truss manufacturer will know that it is laid out that way. You know, top chord bearing. So that's basically this one here. So that's one way of um, framing that one. Or you could do a steel, like open web steel joist. It will be the same um, profile. Instead of wood, this will be steel. But we will discuss this in. I mean, the layout would be the same if you replace the wood truss with what we call this one. If you replace the wood truss with steel joist, open web steel joist, and then usually if you are using a wood truss, then this will be your sheeting would be plywood. You know. This will be plywood sheeting. And then this one is typically spaced at 24 inches on center. Now, if you will use an open web steel joist, then usually this is spaced between 4 to 5 feet. And then instead of plywood sheeting, that will become a metal deck. Or not in the direction, in this direction. Oh, yeah, this will be metal deck, this one. So that will be like that one. That will be metal deck. And then you have to design this metal deck for, shear as a diaphragm, and then at the same time. But we will discuss that in the separate video later on, once we go with, or once we're in the load application. So we will calculate its load, like from the load, from ponding load, from snow load. So we will calculate that one, how it is being applied to the structure. So um, so again, this layout here. So you have your columns. So you have your columns here. uh, have your columns here, then right here you are in the middle of an opening, then you will have like a really big uh, beam there to support the main roof beam. So instead of like maybe a 2 by 4 or 2 by 8, like 3 by 2 by 8, that could be any, it could be an engineered wood, like 3 ply, 16-inch LVL. So um yeah, so that could be another option. Or the other option, if you do like open web steel joist, then you have to do open web steel joist. But most contractor or even owners would first go with the cheapest material, which is wood, unless it is not enough. I mean, you know, wood, especially if the requirement is a non-combustible construction, then you have no options but to go with open web steel joist, steel beam, steel columns. So in that case, yeah, you have another option. But if combustible material is okay, then it is cheaper to use open web steel truss. Now it is also in this same building. Now you can have, so for example, this is your um, building footprint. This one, you know, let's just make it rectangular for the sake of discussion, so it's easy. So you always, like I said, if you use like open web roof truss, like flat truss, in this case, since it is only how many feet, and then it is, I mean, the best option would be spanning the truss this way, and then make it like a mono truss. I mean mono slope. So what it looks like if you cut section, it will look like that one. So that's how you know that's what it looks like a mono slope truss. It will be spanning in this direction. Now, if you notice, this is really long in this direction. So this is what um I can just double check. What the dimension of that building? So this one is 50 foot, 57, 57, and this is 189 plus. So let's just round it off to a whole number. So this is 189 feet, and this is 57 feet. Now, if you are using this as a diaphragm because you will transfer the load to your shear wall, and we will discuss shear wall in different video. But we'll just because we are in the roof framing plan, you have to make sure that you meet the requirements of your roof diaphragm. It has to meet an aspect ratio. So, for example, you know, in this is I googled this one. These are the common um, diaphragm aspect ratios. Now, for wood structural panel block, we'll be interested in this two here. It has to meet this criteria 4:1. Now, what it means is if we are using a block diaphragm, that means your aspect ratio is 4:1. That means this is 4, this is 1. So that's your aspect ratio. So that means if this is 189, you divide it by 4, So that's 47.25, but this is 57. So that means we are okay with the aspect ratio. If this is a block diaphragm, now if we are using an unblocked diaphragm, the ratio is 3:1. If this is unblocked diaphragm, that means this is 3, this is 1. Now, if this is 189, you divide it by 3, that means we need at least 63 feet here. But since this is only 57, no, since this is only 57 feet, we are short, or our roof diaphragm doesn't meet the aspect ratio requirements. And then black diaphragm is quite expensive. So, I mean, it's not that expensive. But one thing to consider also is because if this is a black diaphragm and then this is your entire, this is a single diaphragm, that means only these shear walls are resisting the lateral load. You will distribute all the loads to these exterior walls only. But another option is make this, shear wall, make the shear wall. But in the middle, since you have full height wall here, you have an option to use this as a shear wall as well. And then since if we do like just 3 shear walls, the tributary of this wall will be really huge. I mean, half of the building, you know. So another option is, as long as if this is okay with the capacity, if the capacity of this wall here is enough, then that's fine. If not, then another option is make this also a shear wall. So therefore, if that's the case, this shear wall, if you divide it by half, divide this by half, divide this by half. So this area here will be resisted by this shear wall, and then this area here, one half of this and one half of this will be resisted by this shear wall, and then half of this, half of this. So this diaphragm, and then this one, half of it, this one here. It's just erase this. So we already decided that we are using this as a shear wall. Now to get the load for this wall, all you have to do is get the half of it, and then half of it here, and then this will be your tributary. Now if it will end up really big, or require more length of your shear wall panel, then another option is make this another shear wall. Hmm? So the thing with shear wall is you will do a, like, at least 2 calculations, 3 calculations, then check if the shear wall is okay. That's why it is better if you will make a spreadsheet, like Excel spreadsheet, because this is a repetitive calculation, and then, like I said, you will do a lot of trial and errors. If this one won't work, then you will add another one here. Imagine if you're doing it, by hand. So it's better if you do like if you do a, what we call this one, a spreadsheet, and then what we call this one, you do, trial and error until this shear walls works. So if that's the case, assuming these are your shear walls, so on your roof framing plan, or a shear wall layout, in your shear wall layout, you will have this shear wall in this direction, and then you have shear wall here, you have shear wall there. So this will become a separate diaphragm. This one will be a separate diaphragm. So that will be a separate diaphragm. So we will discuss this more like in detail once we start using or discussing the this topic here. This one, lateral force resisting system. Once we touch this topic, then we will discuss more on that. But like I said, what we are showing now are just floor framing and roof framing layout. But like I said, in a roof framing layout or floor framing layout, you have to consider these aspect ratios. Now, the difference between these two, black and unblack, what it means is, for example, this is your roof. We'll just do a quick like discussion on this one. If this is your roof, and then you will have you will have sheeting, right? Roof sheeting. Roof sheeting usually is 4 by 8. The size of a plywood, standard plywood size is 2 by 8, and then you will stagger the joint, and then this one another, you know, like that. Now, if you remember, our truss is spun this way. That's why it's better to um span your trusses by the multiple of the dimension here. So your spacing could be 12 inches on center, 19.2 inches on center, because 19.2, if you multiply it by, I think, by 5, that becomes 8 feet. I think 5. 5, yeah, 5. If you add, if you multiply 19.2 times 5, it will be 8 feet. So that's why it's ideal to span your or to space your trusses in you know multiple of this dimension here, so that edge of the every edge of the plywood is supported. Now, when we say unblock diaphragm, that's unblock diaphragm. This is your truss, and that's your plywood. But if we talk about block diaphragm, that means you have to provide blocking panel edges at every intersection of the so for example, this is your plywood for the truss, right? So that's your truss, and then you will have joint of your plywood, say like that one, like that, and then this is another plywood. That means at this joint here, if it's block diaphragm, then you have to provide a blocking here, so you can fasten all the edges of your plywood. So if this is your plywood 2 by 8, that means it is supported along all four sides. So that is a block diaphragm. That's why you only use block diaphragm if it's really required. And then especially in this layout also, imagine this is 189 feet. No, I can't imagine what would be the shear wall requirements if we are only using the in walls. So it's better to lay out or use these interior walls as shear walls. So that is a roof truss or roof framing and floor framing layout. So I don't know if you have any question. Um, it's either you can post your questions in the comment section, or you can wait until everything is done. Everything, all topics are discussed, because I might, or well, you can, it's either comment or wait until I discuss everything, and then if it's not clear to you, or if you have questions, you can ask questions, or if you have questions, then you can just comment it or post it or write it in the comment section, and then maybe we'll discuss that in the next video. Or like I said, these are our topics to discuss. So you might have some questions on the lateral force system, but once about the diaphragm, but once we discuss this one, um, I mean, your question, the answer to your question might be uh, discussed once we touch this topic here. So, so that is floor and roof framing plans, and then of course the foundation layout. Well, um, if for example um, this building here now, since we are using a now for concrete, by the way, from last video, if that is concrete, of course, this you have columns here, you have columns. And now, if this is in the proper line, then you have no choice but to have like an eccentric footing, and then this one also, and then to counter the eccentricity, you will tie this together. You will tie this beam together, so it will the tie beam um will resist all the bending, and then you can design the footing as a concentric footing. Now, for wood frame building, if that's the case, then since the walls are load bearing, then you will have like a footing here. You have a wall footing, wall footing, wall footing, wall footing, and then since we're using the interior as wall footing or a load bearing walls, there will be a wall footing, and then if you remember, we have a beam here. So that means if there's a beam, then there's a telepost, then there will be a like a spread footing right there to support. Now, this footing usually, because we are in the in a cold region, then our footing is typically it has to be embedded below the frost line. And typically, what we do is say this is uh, this is your footing, and then this is like your stem. This is still concrete, and we typically specify this to be 5 feet, 5 feet minimum, or not that one, not that one. This hole, or this will be 5 feet, or well, the embedment. So, for example, if your ground is right here, you know, this is your ground. So that means this one from the top of your ground to the underside, this has to be 5 feet minimum. So it depends, like I said, it depends in your jurisdiction. Like I said, here we are in a cold region, then this one has to be at least 5 feet. Well, we have another option. We can use shallow foundation. I mean, thickened edge. So if this is your load bearing wall, we can do like a thickened edge here. So that's your slab, like that one. But if this is the case, we need an insulation here, and then there will be like an insulation here, which is called a frost deflector. So there is a requirements for the R value of this insulation. So sometimes it will be like 5 inches thick insulation, 4 inches. It really depends on the R value requirements. But this is typically um say 18 inches, 18 inches thick around the perimeter. So those are the other option. Now, if we are using steel, for example, in this building, then our foundation could be, you know, let's redo the floor layout. For example, that one. Another option is this will be grade beam. This will be perimeter grade beam. uh, and then we have interior walls. So this will be perimeter grade beam. perimeter grade beam, and then there will be piles supporting this one, depending on the spacing. So there will be piles. It depends on what will be the spacing. So that's another option. Now, of course, all of this foundation option that I mentioned, a you know a spread footing or grade beam or piles, it depends on the recommendation in the soil report. If the soil report says, um, shallow foundation is not recommended because, the ground is not really that good and you need a hard strata, then that's the time you will do a pile foundation. And then this pile could be cast in place or the most common pile foundation here is either cast in place or screw pile. No, so screw pile. This is what it looks like. So this is what it looks like. This one. No, that's a solid. That's not common. Let's say this one. So that one. So that's a screw pile. Sometimes it's called helical pile. This one helical pile or screw pile. So that's the most, or I would say these two cast in place concrete. No, cast in place concrete and screw pile. These are the most common pile types. But yeah, we will discuss that in detail. Like I said, we have that in our topic here. This one here. Types of foundation, strip spread piles. And I will try. Like I said, we will be discussing we will interpret a geotechnical report. I will find another or a sample of soil report that recommends strip spread and piles, and then we will discuss that one by one. I mean, at least help you interpret the geotechnical recommendations. So I hope it is clear now, and so we already discussed that one. Yeah, so maybe in the next video we will start with the actual load calculation and load application, and then yeah, so load application like for concrete, I would say we will only like discuss like an overview in concrete because usually concrete is done by a software. You will use a software to design it, and it's really pretty straightforward because everything are rigid connections. Um, but if we discuss the wood trusses and open web steel joist, it is more, the application of theory is more or is more detail. I mean, like this part here, like load path, you will understand more in on how the loads are applied, transferred from element to element, from roof down to the foundation. If we will discuss if we analyze the structure as a wood or a steel. I mean, of course, there will be load path in concrete building, but because it's rigid, I mean, you know, um, the detailing is not that critical because, for example, your your floor roof diaphragm. That's already part of your slab. When it is rigid, then it will be distributed to all structural elements, to all columns, unless you have a dedicated shear wall or elevator shaft to resist all lateral loads. But yeah, like I said, we will discuss that in detail in the next video. I think that's it for now.